got a great question coming up. It's about the World Cup, and it's on the topic of wave, sound and light. So let's get straight into it. We've got Sandile on the line. Sandile, how are you doing?
I'm fine, sir.
That's great. Great to hear from you. You've called in before, isn't that right?
Yes, I did, sir.
Okay, that's very good. Right, now let's go to your question. It's about the World Cup stadium. Somebody lives, is it a kilometre away from the stadium? And there's no wind blowing on this particular day. And what they hear is they hear the sound of the announcer announcing the soccer teams coming in. But he's listening on the radio at the same time. Is that right?
Yes, that's right, sir.
Okay, so now what happens? Let's just draw the question. We've got the soccer stadium here. So we'll make that the stadium with the lights leaning in. Okay? And what we've got is the person standing over here. He's in his little house, and there he is with the windows. And the distance between these two is 1 kilometre. Am I right?
Yeah, that's right, sir.
Okay, so we've got 1 kilometre. And from the stadium, he hears that there's a sound coming. So there's the sound, and it travels like that. The other thing is that Sandile?
Yes, sir.
The other thing is that he's got a radio.
Yes.
And he's listening to the radio. The radio's got an aerial, and there's the radio. And what he notices is that the opening announcement that he hears the opening announcement on his radio 3 seconds before. So the radio, he gets 3 seconds before the sound.
Yes.
Okay. Now, this is a very interesting problem because they ask you to explain why there's this difference. Have you got any ideas that we might think about?
I don't have ideas, sir.
Okay, let's try and think about it this way. What do we know about the velocity of sound? The velocity of sound in air. When you're doing Doppler effect questions, they say, yeah?
They said we must use 340.
340 or 330 meters per second. Okay?
Yes.
Now, the radio has a certain speed as well. The radio waves are a form of electromagnetic waves. And we know that in a vacuum, they have a value C, which is equal to 3 times 10 to the 8 meters per second. Can you see there's a huge difference between those?
Yes, sir.
Okay. So the reason for the difference, the reason for this difference in sound is that the radio travels from here to a station and then it travels, but it's traveling much faster. It's traveling at 3 times 10 to the 8 meters per second. We can actually work out the time taken, and we can work out the difference in time because we've got that distance. But it's not a true distance because the radio would have to go from here to the broadcast center or to a satellite dish, and then it gets sent to as a signal like that. Now, if you're very careful, and I don't want you to do it right now, but if you look at your TV set, you've turned down the sound. While I'm talking to you on the phone, you will hear that I'm saying something about drawing on the screen, and I've just drawn a squiggle. Now, if you look and see, you'll see that there's a difference in time. Can you see that?
Yes, I can.
I said I'm drawing with the squiggle, and the squiggle wasn't on your screen yet. And that's the reason, because the television wave has to go all the way up to the satellite and then down again, where I'm talking to you on the phone line, which just has to come straight to you via the phone. Okay?
Yes, sir.
So you've got the difference in terms of the distance there. Both of these are, the phone lines use optic fiber cables and they travel very quickly as well, and you sometimes hear it quicker than if you're going via satellite. If you see
Okay.
the difference between TV1 on a satellite station and your aerial, your normal aerial, there's a difference in delay. That's because it's going to the satellites. It's an interesting question. Now let's go to part 2, because we've got to do a calculation here. I hope you've got that sorted out. We're told that there's a man in Australia. The man in Australia is listening to the radio. Is that right?
Yes, that's right.
And the distance, give it to me. What was the distance?
18,000 kilometers.
18,000 kilometers that the radio waves have to travel. Calculate whether you hear the announcement on the radio before or after the spectator hearing it on the sound. So that's what we're going to do now. We're going to say we've got distance, we've got the velocity of the radio wave, which I gave you as 3 times 10 to the 8 meters per second. And we've got the time. We want to find time. How are we going to find time if we've got distance and velocity? And it's constant velocity, remember?
Pardon? Come again, please.
How are we going to find time? What velocity is equal to distance divided by the change in time?
Yes.
Okay, that's the easy formula. So now we want to find time, so let's substitute into that. We're going to say 3 times 10 to the 8 is equal to 18,000. And we want to find time. Do you agree?
Yes.
Now, what are we going to do is we're going to say, let's multiply by time and divide by 3 times 10 to the 8. Okay? You with me?
Yes, I'm with you.
So the time taken is going to be, put the calculator up, clear that one. It's 18,000 divided by 3 exponent 8, which is going to give me a time of 0,000006. Now, if I count up those zeros, it's going to be 1, 2, 3, 4, 5. So it's 6 times 10 to the minus 5. Am I right? 1, 2, 3, 4, 5. Yes, that's it. 6 times 10 to the minus 5 seconds. 6 times 10 to the minus 5 seconds. Now, what we were asked to do is the velocity, we're going to use the same formula now for the man in his village. And we're going to use this value because he's hearing it. He's hearing it at 3,4, and we were told he hears it 3 seconds before. He hears it on the radio 3 seconds before. So it's going to take at least 3 seconds. And where this man hears it in less than a second. So who's going to hear it first? The guy hearing it through the airwaves, normally from the sound, or the radio in Australia?
The radio in Australia.
Got it. Let's just work out the difference in sound. The difference, we'll work out the time, and then we'll work out the difference. So we've got 1 kilometer, which is 1,000 meters, and we're going to take 340 as the velocity, okay? And that's meters per second. Let's see what that gives us. And you'll see 1,000 divided by 340 gives us just about 2,94, okay? 2,94 seconds. Now, the difference between those is less than a second. You can subtract them, and you can see that the man in Australia hears it before. Okay, just remember the crux to this question, the critical part, is that radio waves are examples of electromagnetic waves. Sandili, have you got that?
Yes, I got that.
Microwaves, gamma rays, light, they all travel at the same speed, 3 times 10 to the 8 meters per second. We should say in a vacuum, but we can use it as a general approximation as well.